GRB 230906A erupted where astronomers were not supposed to find it. Not inside a bright spiral, not near a normal galactic disk, but inside a tiny hidden galaxy embedded in a 600,000 light-year stream of gas between larger systems. That matters because short gamma-ray bursts are the last scream of two neutron stars colliding. They are already violent enough to outshine entire galaxies for a moment. Yet this one seems to have happened in cosmic exile, in the dark outskirts where star death was expected to be rare, slow, and almost invisible. And if that can happen there, then some of the universe's most important acts of creation may be unfolding far from the places we usually bother to look. A gamma-ray burst is not just an explosion. It is a forensic signal. In less than 2 seconds, a short burst can announce that dead stars met, fused, and forged heavy elements like gold. The how is brutal. Two neutron stars orbit for millions or billions of years, lose energy through gravitational waves, then crash together in a final instant that launches jets moving near light speed. Andrew Levin and the team studying GRB 230906A followed that signal backward, like detectives following scorch marks after a fire. The burst was detected in 2023. Later, scientists found a white dwarf 10 billion light years away. That light crossed our galaxy in 2023 of all years. But what's even more mind-blowing? This GRB hinted at a collision of two neutron stars. But something else fascinated. These neutron stars had orbited each other for billions or billions of years. Then they crashed, creating an explosion so powerful it changed the course of all time and all space. Like a silent peak show, a celestial supernova. While some stars lose their fuel, this gamma-ray burst outshines a galaxy and creates heavy elements like gold. This is fascinating and overwhelming. Follow-up observations with ground telescopes and the Hubble Space Telescope traced its afterglow to a strange environment. A faint dwarf galaxy sitting inside a giant tidal filament, a ribbon of gas and stars stretched by past galactic interactions. Picture a match flare, not in a city, not even in a village, but inside a torn thread floating between continents. That is roughly the scale of the surprise. And this is where the mystery sharpens. Short gamma-ray bursts have been seen outside obvious galaxies before. Astronomers often explain that with a simple idea. The neutron-star pair was born in a galaxy, then got kicked out by earlier supernova explosions and wandered far away before merging. That explanation still works sometimes. But GRB 230906A does not look like a lonely pair adrift in empty space. It looks tied to a tiny stellar system that itself lives inside debris from a much larger galactic collision. So what are we really seeing? Maybe a neutron-star binary formed inside that dwarf system? Maybe the dwarf was built from recycled material torn out of another galaxy. Maybe these outskirts are not dead at all, just dim. Dim is not empty. That distinction changes everything. The recent relevance comes from precision. In 2023 and 2024, deeper imaging and spectroscopy gave astronomers a much better host identification for this burst than a vague off-center smudge. The projected structure linked to the event stretches roughly 600,000 light-years, an absurd distance on human terms. If you shrank the Milky Way to the width of the United States, this gas stream would run well beyond its borders, like debris scattered into the ocean. Cosmic violence does not always stay where it was born. That idea reaches beyond one burst. In 2017, GW 170817 showed the world that neutron-star mergers really do create heavy elements through rapid neutron capture, the R process. Observations suggested a kilonova, rich in freshly made material, including the ingredients of gold and platinum. The old poetic line that we are made of stardust was already true. But your jewelry, your circuitry, even trace heavy atoms in your bones may owe something to collisions of stellar corpses in places no one would call home. Iron gives us bridges, blood, train tracks, frying pans. Gold is rarer, stranger, more selective. It may arrive from catastrophes taking place in the universe's forgotten outskirts. Do you think GRB 230906A was a kicked-out merger, or proof that hidden dwarf systems are making these blasts in the dark? Tell me which side you're on before we go further. Personally, this is the part I can't shake. We like to imagine the universe as organized into obvious places. Galaxies here, emptiness there. But nature keeps embarrassing that map. A tidal stream sounds delicate, almost harmless, like smoke in water. In reality, it can be hundreds of thousands of light years long, seeded with gas, stars, and maybe compact binaries waiting out insane spans of time. Can you imagine a cemetery of dead stars drifting through galactic wreckage for 1 billion years, only to detonate where almost nobody was looking? There is also a deeper scientific tension. Short gamma-ray bursts help astronomers estimate how often neutron-star mergers happen and where. If some meaningful fraction occur in faint tidal dwarfs, stellar streams, or ultra-dim outskirts, then our census is biased. We may be assigning events to the wrong hosts or calling them hostless when the host is simply too faint to notice. That is a very human mistake. We confuse invisibility with absence, and the consequences are not academic. Host environment shapes delay times, star formation history, metal content, and even how enriched material gets spread. A merger deep inside a large galaxy dumps heavy elements into dense neighborhoods. A merger in tidal debris or intergalactic outskirts can fling that material into thinner space, where it mixes differently and may seed future dwarf systems or halo gas. Think of the difference between dropping ink in a glass and spraying mist across a windy field. Same substance, totally different destiny. That may be the real punch of GRB 230906A. Not just that it exploded in a weird place, but that weird places may help distribute the universe's rarest elements more widely than our clean diagrams suggest. Gold may not only be forged in violence, it may be scattered by exile. But wait, there is another twist hiding inside this story. If a tiny galaxy can survive inside a tidal stream and still host a neutron-star merger, then some of what we call intergalactic space may actually be populated by structures too faint, too shredded, or too temporary for our standard categories. We may not be looking at emptiness between galaxies. We may be looking at unfinished galaxies, recycled galaxies, or wounded galaxies still capable of making stars and burying stellar remnants. That possibility changes how we read the night sky. Maybe the universe is not a set of islands in a black sea. Maybe it is more like a storm-torn archipelago with bridges of gas, hidden coves of star formation, and debris fields where ancient binaries keep their appointments. When those appointments end, they do not ask permission from our categories. In practical terms, this is why wide-field surveys and deep follow-up matter so much right now. Instruments that catch fast transients, then hand them off to telescopes with sharper eyes, are exposing a messier cosmos. Short bursts, once treated as isolated flashes, are becoming environmental stories. Each localization is a crime scene. Each faint host is a witness. And every time the witness turns out to live in some shredded outer structure, the old neat map loses a little more authority. If this burst changed the way you picture empty space, leave a like. Just that one detail, a deadly flash tied to a hidden galaxy in a 600,000 light-year stream, deserves to be remembered. I also think there is something uncomfortably beautiful here. The atoms we prize most may come from systems that were stripped, displaced, and nearly erased from view. Confessionally, that makes the universe feel less like a clean machine and more like a place where loss keeps becoming material for something else. Not kinder, just stranger. Astronomers still need more evidence. The exact history of the host system, the age of the stars in that faint dwarf, and the path of the neutron-star pair are not fully settled. That uncertainty matters. But uncertainty is not weakness when the alternatives are this specific. It is the honest outline of a frontier. So the payoff is bigger than one spectacular burst. GRB 230906A suggests the universe may be manufacturing and distributing some of its most consequential elements in places we undercount, underimage, and mentally label as nowhere. And once you accept that, a disturbing question appears. How many other decisive events are happening in the dark between galaxies while we keep staring only at the bright centers? Maybe that is the real lesson of cosmic exile. The universe does not reserve importance for the obvious places. Sometimes, the flash that helps explain gold, gravity, and galactic history comes from a torn scrap drifting far from the spotlight. Personally, I find that impossible to forget. If stories like this make the cosmos feel bigger and less comfortable in the best way, subscribe. Because out in these hidden structures, the universe keeps saving some of its most important revelations for the places that look empty first.